All right, guys, so we're going to do some free body diagram exercises. There's 12 of them to do, and I'm going to go through and just do 2 examples for you. So from the free body diagram drawing practice, we have a link to the interactive part that you're going to practice on, and then we have a link to the document here, or it's actually down here as well. You could just click on this, and this opens up your own copy. If you click this one up here, you'll have to make your own copy by File, Make a Copy. These are the examples that I did. I might do some different ones. I don't know. We'll see what comes up when I get to this. So we're going to click on the interactive part. And we're going to make this big. You click this big double arrow and it gets larger. And here we see an example of a free body diagram. Each time you get one correct, you get a star for that exercise. So let's see, let's start with number 1. All right, let's try this one. So it says, the cabin of a small freight elevator is secured to a motor by a cable and is moving upward at a constant speed. There is no contact between the cabin and the elevator shaft. Ignore air resistance. Okay. So, whoops, what did I do? So let's draw this on whiteboard Fox. All right, so step number 1. So these are the steps to drawing a free body diagram. So step number 1 is to draw the outline. And usually in physics, you could just draw a box. So here's step 1. That's our elevator shaft. Step number 2 is the weight. They call that the force of gravity. This is also equal to weight, which is equal to mass times gravity. So every time any object is going to have a weight coming down, so that's the force of gravity. Number 3 is the applied forces. So this is anything pushing or pulling on the object. Usually it's FA or something like that. So the F stands for force, right? And the little letter stands for like what type of thing it is. Like this one's force of gravity. So this one's the applied force. Now, there could be different applied forces. There could be frictions, there could be ropes, there could be springs. This one said that it's an elevator and it's being pulled up by a motor. So I'm going to say that this is a force of tension. And I have that on as a note on the page. If you're being pulled by a rope, that is tension, because the rope is in tension. This is tension because of a rope or some type of line, right? It's probably a metal line or something. And then step 4 is the normal forces Now, support forces are anytime you're on the ground. So let's say this box is on the ground. So if when we draw the free body diagram, it's got its weight. And then from the ground, see, we don't draw the ground on the free body diagram. The ground is represented by a force. So that's your normal force. It's remember, normal means perpendicular. So it's perpendicular to the ground and it's what's supporting. Now, in this case, this elevator, the elevator does not have, it's not on the ground. It's in a shaft, right? And it's being pulled up. So there is no normal force. And since it said it's moving up at a constant speed, I believe the arrows will be the same size. So like this arrow should actually be, let me see, let's draw it a little better. It should be the same size. That's about 4 long. 1, 2, 3, 4. So because the arrows are the same size, it's a constant speed. Arrows are equal. So this means that it's constant speed. So let's see if I get this right. So we said downward, we're going to have the gravity. Upward, we're going to have the tension, and they should be equal size. If it was accelerating in either direction, then you can click on it and the arrow gets bigger. See? So I think since it's constant speed, the arrow should be equal. So then you check it, and yes, we're correct. So force tension, force gravity. So then once you get it right, a star will come up. The program kind of mixes up the situations. So let's look at what number that was for us. We just did the football cabin. There's and it's moving upward with the constant. Yeah, we did number 5. So I'm going to say options, snapshot, copy image, and we're going to put it in number 5. So that's how you do these. Any questions on that, guys? Do one more for you guys. You could type your question in the chat. All right, no questions. All right, let's do one more. Let's see what comes up. Let's pick situation 8. A rightward force is applied to a dresser, okay, so like a chest of drawers, right, to accelerate it to the right. So it's accelerating to the right, or you're right, right? Ignore air resistance, okay. So we're moving a dresser and it's accelerating to the right. So let's practice. Close all these. All right, so what's happening is if you guys have ever moved your drawers, maybe it looks like this. And then you got, you know, something like that. All right, so it's on the ground. And somebody is going to push it. Ooh. There we go. All right, so he's trying to push it to the right, right? So let's draw what's happening. So this is your dresser. This is step number 1, the outline. So he's trying to push it to the right. So he's pushing this way. Let's draw it on this side. So that's it, the force applied, right? That's him. And then this dresser weighs a lot. Force of gravity. So step 1 is the outline. Step 2 is the weight, which is this right here. Step 3 is the applied force. And then, okay, so when this is something to remember too with friction. Friction, anytime something is on the surface, friction is opposite the direction of movement. So when you push against something, you feel like it's hard, right? And so that's friction. So let's put in that force of friction. Now, it did say that it's accelerating to the right. So actually, let's make this smaller. The friction's not that big. So it's going to accelerate to the right because the arrow is larger. And then we need one more, the normal force, the support force. This thing, according to the way this is drawn right now there is no normal force. So this is just floating in the air. But we know that it's on the ground, right? So what's represented by the ground is this normal force. So we've got gravity, force applied, the friction, and then the normal force. Remember, normal means perpendicular to the ground, and it's supporting the weight of this thing. So let's see if we're right. So we've got downward gravity, upward normal, rightward applied force, and let's make it bigger. And then leftward, let's do friction, like that. So let's see if we're right. Yes, it is correct. So most of them are going to look like this. If it's in the air, you're not going to have a normal force, right? And if you're not on the ground, you're not going to have friction. So those are things to keep in mind. So that was number 8. Let's see. Copy. And this was number 2. So you guys got number 2 and number 5. There's some other ones on there. So I did 4 of them for you guys. And that's the end of the recording.